Good afternoon, ladies and gents. My name is Michael Messele. I am CEO of Etherspot, and in this workshop, we will make the case for using the free Infra 7702 Infra provided to us courtesy of the Ethereum Foundation. Then we will take you through the architecture, then run code examples for you if you have your laptop so you to participate with us. So why do we care about 7702? Well, through 7702, EOAs get a new lease of life. They pretty much behave like a smart account in that your users can benefit from one-click action transactions and courtesy of transaction batching, which means if you have a set of transactions that the user has to sign 5, 6, 7 times, they can just sign once. And they can pay gas fees using stablecoins or other ERC20 tokens. You might even decide to sponsor their transactions. So imagine if you have a subscription service where you don't want the users to know much about gas payments or any of those details, you can just sponsor them and they can use your service, effectively abstracting away the gas complexities. You can even take advantage of complex structures such as session keys. Now, let's say adoption trilemma in terms of Web3 spaces: ease of use, which is usability, security, and self-custody. And think of the recent outage from Amazon services and how many Web3 services were affected. So you can question yourself, are we beginning to sacrifice self-custody? In fact, think of the balancer hack recently and how different teams decided to mitigate them using centralized mechanisms. Then you ask yourself, how are we future-proofing the ecosystem from unforeseen disasters? Think of the 2008 run on the bank scenario. If such a thing happens now in a month's time, with pretty much DeFi with near total exposure to dollar-denominated stablecoins, how would the ecosystem fare? And where does this leave us with anyone who wants to censor us? Is it a big leap to think a certain jurisdiction might demand the same centralized mechanisms to be used because they want to censor certain wallets for their own reasons, the same mechanisms used in recovering or mitigating the balancer hack? Is it a big leap to imagine a certain jurisdiction saying to infrastructure providers, go and get me geolocation-based information on wallets from A, B, C jurisdictions and filter them and give it to me? Then as soon as they get them and they go and say to the stablecoin providers, freeze all stablecoins in wallets in these jurisdictions, then are we becoming the efficiency layer of TradFi, hence FinTech 2.0? That's why we desperately need to strengthen our efforts in building non-custodial decentralized solutions. We desperately need to do so. The EIP-7702 infrastructure is free to use, as I've mentioned, to integrate for any wallet that integrate it. And it is easy to integrate as well because it is leveraging VM library. It's just simple to integrate. And it leverages the tried and tested ERC-4337 infrastructures. This leverages shared mempool. What shared mempool is, first of all, it is using gossip protocol, and it is inspired by the Ethereum consensus spec. And with the shared mempool, one of the biggest advantages, because as soon as a user operation comes into the mempool, it is distributed amongst many bundlers, therefore eliminating a central point of failure. This actually is useful from the business perspective, where nowadays mature projects are asking us, as well as institutional clients, to give them SLAs with 99% of the time uptime. Now, with simple usage of the shared mempool, we eliminate a point of failure, a centralized point of failure. On top of that, because all the bundlers are open source, I can spin off a bundler and process my own transaction. So if all the bundles were censored, I don't care. I've managed to process my transaction. So it is very important in terms of achieving non-custodial ecosystem. However, the adoption for the shared mempool has been very slow, and it's been live for over a year. And then it begs the question, are we as an ecosystem sleepwalking to a disaster, towards a disaster, a centralized disaster, which we haven't foreseen yet? With the advantage 7702 brings to EOAs, new era for EOAs, we cannot take the backward step of forwarding our user operations to centralized bundlers. Even worse, the, relying on centralized relayers to process the transactions would be a massive backward step. The 7702 infrastructure, the free infrastructure, is available on up to 8 chains or 7 chains, and it will have a 24-hour support service. And right now it is available on Ethereum, Optimism, and Arbitrum, and quite a few wallets partake and few bundlers partake in it. And what I will do is I will show you a use case by one of the projects that integrated it. Pillar projects, PillarX, they have implemented the 7702 upgrade, and then with as soon as the upgrade is done, you can see the EOA using a simple batching of transactions where a user is sending USDC to one address and Ethereum to another address in the same transaction. And this is a simple case, but wallet service providers, you can think of the very complex things you can achieve. And you can see as soon as you send the transaction, you can see it in Etherscan under the 7702 tab. And as I said earlier on, this is a new era for EOAs, where one-click action transaction is right here, right now. As you can see, it is straightforward. And now I've given you the introduction as to why we need it and made the case. I will pass you on to my colleague Nikhil. He will take you through the architecture of 7702 and take you through real use case code examples, which I would encourage, if you've got a laptop on you, to pull it out and take part with it. Thank you very much.
Thanks. I'm Nikhil. I'm working at Etherspot as a backend engineer. So in this video, I'll be giving a step-by-step guide on how to construct 7702 user ops and make use of Ethereum Foundation's bundled infrastructure built specifically for entry point 9, managed and hosted by Etherspot, and how to use this infrastructure to send your 7702 user operations, and what are the various steps involved for this 7702 user operations. So I'll be covering all of these in this video. So let me share my screen. And yeah, and little more about this Ethereum Foundation's infrastructure. It's completely free to use. It's 100% free to use. It's public and it's censorship resistant. So currently it's being supported on 6 chains, including Ethereum, Optimism, Arbitrum, along with their corresponding testnets. So these are the 6 chains on which this infrastructure provides support for currently. We'll be adding support for other chains in the coming weeks. And this is built specifically for entry point 9. Uh, so yeah, uh, so you wouldn't need any API keys or it doesn't have any rate limitings. It doesn't have any limitations on to use this. So you can use it for free completely. So yeah, moving on, I'll head over to docs.erc4337.io, which contains a section called 7702 user ops guide. Head over to this section. So this section should have all of the documentation needed to make use of this free bundler infrastructure and how to integrate to this. Yeah, so I'll start by cloning this repository. I already have this cloned. If you don't have this cloned already, then please clone this repository. My GitHub username is nikhilkumar1612, and you can find a repo called 7702 examples. Clone this repository to your local. I already have it cloned, so I'll open that now. Uh, yeah, so I've cloned this. Once you have cloned, run npm I to install dependencies. Uh, and I'll create a new file called test.ts to test, uh, all of the utility functions this SDK provides. So yeah, run npm I etherspot free bundler SDK. So etherspot free and bundler SDK is a SDK uh, which is a provision provided by Etherspot to connect to Ethereum Foundation's bundle infrastructure. So it has support for both NPM and Bun. So you can use whatever you're comfortable with or whatever suits best for your project. So I'll use NPM. It's already installed, but yeah, I think this should install the latest version of my of Etherspot free bundler SDK. After that, moving on. So the first function we'll be seeing is how to get the supported chain IDs. I'll copy this, head over here, paste this, and then I'll add a log to see what this returns. To run this, I'll say npx pfx s.c/s.ps. So this should give me the various chain IDs which are supported. Like I said before, these are the 6 chains for which Ethereum Foundation provides support for. Uh, it's Ethereum mainnet, Optimism, Arbitrum Sepolia, and Optimism Sepolia. So these are the 6 chains. Moving on to the next one. How to get the bundler and RPC URL for any given chain ID which is supported. So I'll copy this, paste, and then say bundler RPC URL. I think an import is missing. I'll import that as well, and I'll run the same file again. So this should give you the RPC URL which has to be used uh, to create a bundler client or to use this URL to connect to the bundler. Also, one more important thing to note here is that Etherspot Free Bundler SDK is not mandatory to have access to Ethereum Foundation's bundler infrastructure. It is just a provision provided by Etherspot to have a few utility functions and to have a function to create bundler client. That's all. So if you don't want to use Etherspot free bundler SDK and still access the bundler infrastructure, you can always do that by using this URL, which is rpc.erc4337.io slash the chain ID to which you want to connect to. Yeah. So moving on, how do we create a bundler client using this SDK? So I'll copy over this function here, over and paste this here. I'm trying to connect to Ethereum mainnet, which is chain ID 1. I think this is not imported, so I'll import this mainnet. And this function is not imported, importing this, and then public actions, uh, wallet action. Uh, yeah, so this is how you create a pre-bundler client. In this case, as you can see, I'm calling it twice. The reason behind this is just to showcase the client bundler client, whatever is returned from the create bundler function, it can be used to extend it for public actions and wallet actions as well. What this means is so this particular URL rpc.erc437.io is not just a bundler client, it is a not regular RPC client, JSON RPC client as well. So you can use this for any of your regular operations, like if you want to make any RPC actions, normal RPC actions, you can use this URL for that purpose as well. So all you have to, if you are trying to send user operations on entry point 9 on any one of these chains, then this is the one URL which you would need for all of your operations. You do not need a separate RPC URL as well. So this URL serves as both a bundler client as well as a normal RPC client as well. So yeah, that's how you create a bundler client and extend it to be a common client as well. Moving on, I'll head to the next section now, which is constructing the user operations itself. Uh, so there are three steps for any 7702 user operation. So the first step is to create a smart account client to which you want to connect to, which would need a delegate address and what are the various implementations needed for that particular smart account implementation. Um, yeah, so in this case now we will be using two simple 7702 smart account. Uh, so I'll copy this. Mm, And I'll create a new function here for main and paste whatever I copied. And then, so that is the first step wherein you create a smart account client. Uh, Once you have the client, so the second step is to sign the authorization. Now, what does sign authorization mean? Sign authorization is something wherein EOA is allowing a particular deployed smart account address, which is already deployed. EOA is trying to authorize that all of its calls can be delegated to it. That's what signing authorization means. So once we have this sign authorization, we make use of the 7702 auth tuple and then send it to the bundler. And then bundler recognizes this 7702 auth tuple and sends a type 4 transaction with authorization list, whatever we got from the signature of EOA. Uh, yeah, after that point in time, the EOA is now no longer a regular EOA. It becomes a delegated EOA. So all of its calls would be delegated to a already deployed smart account. So yeah, that's the second step wherein you generate authorization, you compute the authorization for the connected EOA, and then send it to the bundler for sending the user operation. So yeah, these are the two steps which are involved in any 7702 user operation. So I'll copy over this sign authorization part and then the part where we actually send the user operation. and copy this. We need this. Copy all of this. Head out here. Uh, I'll indent this a little. Remove export. I don't need that. And then this as well. So there are a few import issues. I'll fix those now. Argument. Let's smart account, private video account. Okay. Yeah. So I'll use the .env package to use my private key over here, and from .env, I would say .env let config, and I'll replace this with my env. And also heading over to the env example here. So these are the two envs which you would need. The bundler URL is optional, but the private key is mandatory. Uh, So if you want to override and use a different bundler URL for any reason, so you can use this env and have a URL override infra's URL. But yeah, private key is mandatory. Do this and fix should fix that. Okay. Now I have the complete code for how to send the 7702 user operation for using entry point 9 and a simple smart account 7702 implementation. So yeah, this is something which VM provides us definition for. So it contains the logic for what are the various operations needed and how does this particular smart contract behave. Uh, so yeah, we are making use of that from VM, and then we are overriding it with the current entry point 9 address because this is VM does not have support for entry point 9 yet. It only has support till entry point 8. Because we want to use entry point 9, I'm uh, overriding the entry point address here. And then I'm just logging the smart account address. After that, we are checking if what is the sender code. If the sender code is already delegated, then we do not need the authorization because we'll be just wasting unnecessary gas. So that's what's happening here. I'm trying to get the sender's code and checking if it is already delegated. If it's already delegated, then I wouldn't sign the authorization. Otherwise, I would sign the authorization and then use the client which we created previously and then call dot send user operation, and that should submit the user operation to the bundle. Uh, yeah, let's run this now. TSX. Oh, I think I did not call the main. So what? Run this. I think I do not have enough funds on Ethereum mainnet, so I'll be using Specula. Uh, Copy this and then use Specula. So in this user operation, I'm trying to do is send the native ETH to a particular address, but it can be anything else. So calls field in send user operation takes an array, which can be to value and data. So according to your use case or according to your use case, so these fields might vary, or you can even have multiple calls. So yeah, this was the tutorial on how to send 7702 user operation using Ethereum Foundation's bundler infra. Now, I'll show you one more example now, wherein it will be account specific. For this, for the sake of demo, I'm choosing Amber here. As you can see, how is this different from the one which we just saw? So it's like if you have your custom 7702 implementation, then and VM does not have support for your smart account client, it's obvious that you wouldn't have support for every possible smart account clients like we have for two simple 7702 smart account. So how do we create our own custom smart account client? So that is what this is about. This will be focused about. So here I'm trying to create one for the wallet which I've chosen. I'm using two smart accounts from VM, and I will provide it all the details like client. This is the client which we created. So it's the same thing which we saw previously. We are using create free bundler and extending with public actions and wallet actions as well. Uh, and then I'm specifying what entry point to use. So this is my latest entry point 9 address, and I'm using dot dot 8 over here because just to be type safe, because VM does not have support for entry point 9 yet. I'm just doing this just to be type safe. That's all. And then there is encode calls. This is the function which will have specification for how to encode your calls, how to encode your call such that it would work on your smart account implementation. For example, in our previous example, we s- gave a calls array. We specified a calls array over here. So this calls array will will reach here eventually during send user operation, and it would know how the call data field for user operation should be encoded. So that's what this function is for. According to your implementation, how do you want to execute your call data, and how do you parse the call data for your for the field call data in the user operation on entry point? That's this is the function for that. So yeah. And then we have decode calls. Decode call does the exact opposite of encode calls. Whatever you encoded, the exact opposite logic for how to decode the call. So decode calls takes in a hex data, and it would return calls array. Whereas encode calls takes in a calls array and then return your hex data. So it's that. And then there is authorization field where you can specify what is your delegate address and what is the account you have to use to sign that. Uh, yeah, that's authorization part. And then get address, of course, for 7702 transactions, uh, both the EOA as well as the smart account address would remain same. But yeah, this is one of the functions which is mandatory to, s- mandatory to specify when you are using two smart accounts. Yeah. And later, this get factory asks for any 7702 user operations. Factory would be 7702. These two fields will be used to populate init code field on the user operation. And then there is factory data. Depending on your use case, this might have some data. In this case, I just have it as empty. And then there is get stub signature. This is required during the ETH estimate user operation gas call. Uh, and then we have sign message, which specifies how does the smart contract account, smart wallet account signs. And then sign type data. How do you type in 712 signature and then sign user operation itself? So So this is something which will get called when during send user operation call, because you would have to sign the user operation hash which we generate. So what happens for the wallet which I've chosen here is uh, I'm converting it to a packed user operation. I get a packed user operation, and then I'm computing the user op hash, and then I'm decoding the function which I need for this specific wallet implementation, and then I'm getting the 712 data, and then I'm using signed type data to get the signature. So once I have the signature, I'm just returning it over here. So uh, yeah, that's sign user operation. Uh, and then yeah, I'm just logging my wallet address, and then rest of the steps remain same. You check for sender code to see if it's already delegated or not. If not, then you delegate it to a sign the authorization and delegate it to a particular address. Uh, and then yeah, send user operation. As you can notice that in this example, I have a calls array. So this is how the batching happens. So in one single user op, you can send multiple calls. So yeah, uh, yeah, that's all. Let's try running this once. Uh, NPS PSX accounts and send. So here I am using Optimism Sequoia chain. Yeah, let's open this. So you see authorization is undefined here because it was I used an already delegated account. If your account has not been delegated already, if you are using a fresh account, then you would see a signature uh, signature return value from sign authorization, which would typically contain the signature fragments RSV values, the chain ID, nuns, and then the delegate address to which you are trying to delegate, which will be in this case uh, this address. Yeah. So let's see what happened with this transaction. I'll head over to Optimism Sepolia. I'll choose testnet. I'll paste my EOA account. As you can see, this is already delegated to my implementation address. We can see this address is this address. And then internal transactions. You can see there was a transaction 45 seconds ago. I can open this. You see, I did two operations here, two normal send ETH calls. So one is to this address and the other one is to this. Uh, and then yeah, that's all. Rest all is the remaining, transfers for the relay account, which is normal in any entry point transactions. Uh, yeah, and then moving on. Uh, So if you don't want to try this on your local or if you just want to give it a try, then you can always open Stackblitz. Uh, yeah, this will typically clone the Etherspot free bundler SDK, for which this is the GitHub link. You can find it under Etherspot organization and free bundler repo. So this is basically the whole repo which we use right now in our examples. So if I can head over back to Stacklet, so this is the exact repository which it clones, and then there is an example folders over here. If you don't want to, set up your development environment and you don't want to clone this repository, you just want to try out a transaction, then you can always head to this Stacklet URL and then use this. Uh, so there is an example folder over here, and there is a usage.md file. I can open that. Uh, examples usage.md. So yeah, this will contain like the total guide on how to use the examples folder to send a user operation. So you typically need to pass in a private key and then yeah, that's all, a private key. Even if you don't send the chain ID, it will default to Sepolia network and it will use simple 7702 like we just saw. Um, then yeah, optionally you can even pass the paymaster if needed. So for that, you would use paymaster URL and paymaster context. Yeah. And moving on to the last one. So sponsored user operation. So what are the steps needed if you want to have your 7702 user operation sponsored? So there'll be one extra step that we would have to follow. That would be creating the paymaster client. Uh, we do that using VM account abstractions create paymaster client function. Uh, just use this functionality to create a paymaster client and then paymaster context depending on what URL you use over here and then create a paymaster client. Uh, now we have paymaster client and paymaster context. Just use that in the send user operation call, and that should have your 7702 user operation sponsored. Uh, yeah, that's the one extra step that has to be followed if you want your 7702 user operations to be sponsored. Yeah, that's all I had for this tutorial. Uh, Thank you all for watching. Bye bye.